Welcome to the Science Experience podcast, where we explore the latest and most exciting papers and preprints in science. And hey, if you find this deep dive insightful, please do hit that like button, subscribe, and maybe share it with friends and family. It really does help support the Science Experience. So today we're diving into something pretty crucial, a roadmap for alleviating the manifestations of aging in the cardiovascular system. Sounds complex, but the core idea is fascinating. Think about your circulatory system, not just, pumping blood, but acting as a kind of gatekeeper for healthy aging. Understanding how it ages specifically seems key to, preventing or at least lessening age-related diseases.
Yeah, and what's really empowering here, I think, is the distinction the roadmap draws between your chronological age, like the number on your birthday cake, and your biological age. That biological age reflects the actual molecular, cellular stuff happening inside you. It's a much better picture of your health status. And crucially, it's potentially modifiable.
Modifiable, okay. So it's not just about how many years you've lived.
Exactly. It's about how well your most vital system is actually functioning during those years. Optimizing health span, really, not just lifespan.
That's a big shift. So if we can influence this biological age, what are the cellular bad guys this roadmap points to? What drives the aging in our heart and vessels? Let's maybe unpack some of those hallmarks of aging it mentions.
Absolutely. So a big one is cellular senescence. Sometimes people call them zombie cells, which is, a bit dramatic, but gets the idea across. These are cells that have stopped dividing, which might sound okay, but they don't just disappear. They hang around and become, detrimental. They start spewing out this mix of harmful stuff called the senescence-associated secretory phenotype, or SSCP.
SSP, okay.
And that's bad news, especially for the endothelial cells lining your blood vessels and also the vascular smooth muscle cells. It directly contributes to problems like arterial stiffening.
Arterial stiffening, right. So these SSP factors are like tiny little troublemakers inside our arteries. And the roadmap mentions something about contagious aging. That sounds
worrying. It does, yeah. But it describes the process well. That SAP mix isn't just localized. It can actually nudge neighboring perfectly healthy cells towards becoming senescent, too.
like a domino effect.
Sort of, yeah. And this creates this persistent low-level inflammation throughout the body. We call it inflammaging, inflammation driven by aging. And that process just slowly erodes health. It's a direct contributor to things like blood vessels losing their elasticity, making them less flexible.
Okay, so you've got these tiny cellular issues adding up to big real-world problems, like the arterial stiffening you mentioned, heart failure. And it seems linked to other age-related things too, like cognitive decline, kidney problems. It really shows how connected everything is.
It really does.
But it's not all doom and gloom. The roadmap talks about strategies to fight back, right?
Definitely. Lifestyle is still huge. Regular exercise, amazing for endothelial function, reduces inflammation. Dietary changes, too, like the Mediterranean diet, maybe caloric restriction, intermittent fasting, things people are already hearing about.
Right, the classics. And on the medicine side, Gerotherapeutics.
Yeah, that's the exciting frontier. We're seeing promising agents like senolytics designed to actually clear out those senescent cells, also NAD plus precursors, and, interestingly, SGLT2 inhibitors. Those were originally for diabetes, but wow, they're showing some really interesting heart benefits.
That all sounds incredibly promising. Senolytics, NAD plus RG, SGLT2 inhibitors. But connecting this back, what are the main hurdles, the challenges this roadmap highlights in actually using these things widely?
Well, that raises a really important point. While a lot of this stuff looks great in lab animals, mice, the solid clinical evidence in humans, for most of these gerotherapeutics specifically, it's still lagging behind. We need more robust trials. And a big challenge there is that older adults, especially those with multiple health issues, multimorbidity, they're often left out of these crucial trials.
So the very people who might benefit most aren't always included in the research.
Exactly. And another really key area is understanding the differences between sexes. Women tend to live longer, but often with more years of age-related health problems. Things like hormonal changes around menopause play a big role, and cardiovascular disease can present differently in women. It challenges that old view of it being just a male disease. We definitely need more tailored approaches. Oh, and related to cellular function, thinking about things like complex 1 in the mitochondria, those specifics matter too.
Complex 1, right? So tailored approaches, more inclusive trials. It sounds like the goal isn't really stopping aging dead in its tracks. That feels a bit sci-fi.
Probably, yeah.
It's more about stretching out the healthy years, our health span, giving us more vibrant, active time.
That's the realistic and, frankly, more desirable goal.
So maybe imagine a future where interventions are truly personalized,
Yeah.
based on your actual biological age, maybe your sex, your specific risks, interventions that could genuinely delay heart disease related to aging.
That's the hope. A future where we live not just longer, but healthier for longer.
A future where more years are good years. That's definitely something to aim for. Okay, that's all the time we have for this deep dive. If you enjoyed it, please remember to like this video and subscribe for more journeys into the world of science. This has been the SANS Science Experience.